This question is on wave and you're given a water wave in a Ripper tank and the wave is moving to the right. Okay, since they say that it changes from 3 to 1.5, the distance between the troughs. All right, so we can assume it goes to the right. But in this case, even you treat it going to the left, it doesn't matter. The way to solve this is the same. All right, now let's talk about the 3 cm and the 1.5. This is one trough to the next trough, so this is actually your wavelength. Okay, I can also do something that you are familiar with. If I were to look from the top view of the Ripper tank, you will see that let's draw something that you are familiar with. If I were to join all the crests, adjacent crests together, you can see that all these horizontal parallel lines, they are called wave fronts. All right, now of course wavefront, I choose to join all the crests. You can choose to draw all the trough. That means you can choose to draw all here. All right, joining all the trough, up to you. So the distance between two wavefront is your wavelength, which is in this case 3 cm. Okay, because crest to crest is 3 cm, is the same as trough to trough. All right, so these are things that you need to know, and you know that the wavelength becomes shorter, 1.5 cm, as it goes to the region on the right of PQ. Next, you are given that the speed of the wave at R is 0.15 meter per second to the right, and you're supposed to find the speed of at point S. All right, so and this one is mentioned already, so that is the wavelength here. At you can, let's call the left side as R and the wavelength of the right side is the S. All right, so the first thing to remember is once the wave is produced, there's a physical quantity that will remain constant, and that is your frequency. Frequency will remain constant as the wave moves from the left to the right, because the frequency depends on the source. Let's say the dipper that goes up and down and disturb the water, the frequency will follow the frequency of dipper and it will stay constant as it goes from deep to shallow or shallow to deep waters. So once we know that, okay, you can just you can do in this way. The frequency of R definitely must be equal to the frequency of S. And using the wave equation, V equals to F lambda and F equals to V over lambda. That means to say I replace it with the speed of R over the wavelength of R is equals to the V of S over the wavelength of S. Then what you need to do is just to sub in the value, and VR is given 0.15 and the wavelength is 3.0 cm. And over here, the speed is what you want to find and the wavelength is 1.5. Now, why do I prefer this kind of working is because you see, here the speed is meter per second, but the wavelength is in cm. So if we were to do this to find the frequency, all this must be of consistent units. That means to say maybe I need to change this cm to meters. But if you do your working in this way, it is very more straightforward, because here as long as both sides the wavelength is cm, okay, and you no need to change because it will be cancelled off. All right, so you just need to solve for your Vs, and the answer will be 0.075 meter per second. Since the speed is in meter per second, obviously the speed here will be meter per second also. So the answer will be A. One thing to take note of, when for a water wave to change its so-called wavelength, it must be about going from deep to shallow or shallow to deep. So deep water is over here. Just remember, in the deeper region, the speed of the water is faster, and this is a shallow region. That's why the speed slows down and the wavelength will be shorter. All right. Hope you understand now. Thank you.